Let me go to the whiteboard. Do you see whiteboard now? Okay. So basically, today is the day, I don't know, between another thing, that we study determine domain and range of the functions. The first thing we are learning is determine domain and range when it's given the graph of the function. As I put here, 1, 2, 3, three examples. One easy, one intermediate, another extremely complicated, similar to the test, it's always complicated, in which, look in the graph, you determine domain and range. Let me try to understand, okay? Recall again, domain. What is domain? This is a famous word that we use in every day. Domain is a set of X value. Of course, in which the function is defined. To be defined means that when you plug it in any value here, you get the number. Because another possibility is that you get nothing because it's undefined. 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 Undefined is nothing. Undefined is nothing. It's no solution. It's nothing. It's the word that the mathematician create today. Nothing. No value. No value. Okay, entonces es super easy. Let's focus in the first example. Make a zoom. Well, this is a line, straight line. Nice. Well, I try to do a straight line. And this arrow indicates us that this graphic continues forever in that direction. So that means if you continue doing the graph, you are doing in that direction. But the paper stopped here. So that is the reason I indicate it's infinity in both directions. Use no that. Okay, if you want to find the domain, look in the graph, no mathematical, only look at the graph. Look. I know domain T. Can you take point on the curve, on the line, on the curve in general, and you projecting onto the x-axis because the domain. One by one infinity point we have when you projecting, I can see clear that the domain is the entire x-axis. The domain is from negative infinity, comma, positive infinity. In this case, que es elementary, the range, que es similar idea, but y value, you projecting onto the y-axis. And in this case, you see again that the range is again all real number. The range is all real number. The real number expressed in interval notation is like that, no? From negative infinity to positive infinity. Do you understand this idea or is confusing? Clear or confusing? Clear, super. Now let's go, move on to the second example. The second example, a little bit more complicated. In this case, it's a parabola, no? It's a curve, and this curve open in both directions. This arrow indicates this container open in both directions, right and left. Now domain is obvious again, is similar, is all real number. So because we have no undefined, it's defined for all real number. The domain is column all real number. However, the range no. Because when you projecting any point on the parabola, on the curve, doesn't matter the name, onto the y-axis, you can see, for example, when you're projecting, okay, you're projecting here -3, you're projecting here 2, but we have no parabola, we have no curve in -4, -5, -6, therefore, our range is from -3 to positive infinity. Okay, so the answer is from -3. Remember the interval notation. You separate two numbers or symbol by a comma, no? And you put first lower bound, the lower bound is -3 in this case, and infinity positive. Now include -3 is a touch, physically, touch, -3. But you know, infinity is a symbol and never touch because it's continue forever in positive direction. And this is the range. Any question about the example 2? It's easy or complicated? So I try to illustrate using the color, no? Domain is blue and range is green. Let's see number 3. And number 3 is a more complicated function. And this more complicated function involves this new symbol. You need to be familiar. For example, this symbol indicates the whole. A whole, the interpretation of the whole is undefined. When you see in one function a whole, it's because we have no value of y associated with this. It's a whole. Another way, okay, when you talk about interval, suppose interval, and the endpoint is like that. For example, this is open and this is closed. Okay. But this is undefined, and the open is undefined, and the close is defined. Entonces, another symbol is like that, no? Okay, this is no hole. This is defined. Defining. I emphasize like that because normally when you have inside the interval, not necessarily put the symbol, no? I suppose default. Okay, everything is defined in the middle of this. Okay, ready to the complicated part. Domain. Domain, remember, is the projection, any point onto the x-axis. So I suppose that this arrow indicates continue forever to negative infinity, this is negative infinity. But here, in -4, we have a hole.
I can't hear.
What's going on? You asked me something? Okay, putting off the microphone, please. Let me see. Randy, no? Randy, everything okay? Randy Profetti. How's it going? Okay. Okay, guys, focus. This is a complicated part. So now we continue domain. In this case, wow, look at that. In this case, we have double. We have close and open. And close and open together, of course, is close. You want to put like that or not necessarily like that. You suppose the default is this continue here. Here and 2 is close. And between 2 and 4, we have a gap. A gap. A gap is a space that we have no value of the function. Gap. Entonces this is a hole, another hole, and continue forever. Okay, ready. This blue collection of the interval represent the domain, que is from negative infinity, comma, -4, no incluye -4, union, -4, comma 2, que is the second part, union, because we have 3 pieces of the interval, is from 4 to infinity. Of course, no incluye 4, no 4, and infinity. So we have 2 whole, and -4 and +4. We have 1 gap in between 2 and 4, and this is my domain. Any question? It's complicated or no? No? Yes, no, answer me. Clear, super. Let's move on to the range, because sometimes range, sometimes not always, it's a little bit more complicated. Remember, range is the projection. Projection, but in that case, onto the y-axis, because range by definition is y value. So when you, let me use in green color, projecting here, you can see that this is coming from this. Because this line is tending, you know. But here, stop a little bit. But we have double value. Well, this is whole, and this is no whole. So stay the whole. So whole plus no whole is obvious que es no whole, right? It's the union, the connection. We have a gap. We have a gap here in between 2 and 5. Remember, we are talking about y value. Entonces, let me try. It's from negative infinity, coma, 2, ¿no? Coma 2. And include 2 because touch physically here. Union. Let me see. We have another part here. Que is this part. Sorry. Green color. That part. Que is from 5 to 7, no? From 5 to 7. No include 5. And include 7. Noise. Union. Who making noise? Guys, quiet. Also, no more interval. No more interval because that part was included in this. Okay. Entonces this is totally not necessary. Okay, this is the idea of the. This is no infinity. This is stop here. Stop and 7. Okay. And another part is overlap, like this part and this part overlap. You consider one time. Okay. Entonces, you need to be aware that in the test, I put a complicated example in which maybe you have a holes, we have a gap, and you need to determine graphically, no mathematical domain and range. Any question? No? Okay. Let's continue with the domain, but in different way. Now determine the domain. No range, because range sometimes is very wide, is not positive infinity. Because my graph is stopped in 7. Look, in the Y projection, que es the green one, we have no value here. My graph is stopped here. Okay. No, this is this example, no? Another example maybe yes, continue, but in this example, no. Determine the domain. Clear, mister, or no? Yes or no? Answer me. Okay, super. Using equation. Okay, in this case, no graphic anymore. No. Now it's given the equation or the expression, much better, of the function, and you need to determine domain. No range, because range sometimes is very, very, very complicated. Never, I ask you, when you have equation, range. Sometimes it's super complicated. Sometimes no, but sometimes yes. Thank you. No problem, guy. Randy. Okay, look. What is the problem? What is the agreement that we are using? To find the domain of any function, you assume that the domain is all real number, except restriction. What means restriction? Restriction means the value in which the function is undefined. It's synonymous to say undefined. Entonces, what is the case que we have? Well, we have 3 basic cases, and they are combinations. For example, case number 1. Suppose you have a function that represents the division, two functions. P and Q represent two expressions, algebraic expression. Entonces, the domain es obvio que es when the Q is not zero. Because you know que division by zero is totally illegal. Division by zero is undefined. Then in order to find the domain, I don't care, the top part is totally irrelevant. You take the expression in the bottom, you enforce it to be not zero, and this is the set of the value to satisfy the domain, because this is restriction number one. Restriction number two is when you have square root of any expression. The domain is when this expression E without root, I remove the root mentally, is greater than or equal to zero. Because si es a square root negative number, you know que es imaginary. And imaginary, guys, is totally out the domain, que the supposition is all real number. Okay. And the third one is when you have P divided by radical E. That you have fraction. But in the denominator, we have radical, square root, no? So the domain is like a combination, this and this together, no? Is when the expression E is positive. No equals zero because equals zero undefined by the reason number one. And their combination. Okay? Because sometimes, why combination? Because suppose you have a function that contains two radicals. Then you apply one restriction here and one restriction here. Okay, let's see example. Do you understand very well? Keep in mind this restriction, guys. 1, 2, 3, 1, 2, 3, 1, 2, 3. I repeat 50 times throughout the course because this is important. Let me go to the example one. Example one is one function, okay, the name is f of x plus 4 divided by x squared minus 2x minus 3. And so the question is, determine the domain and express the answer in interval notation. So always in the test, guys, interval notation. This is a classical notation that we are using. Okay, so I identify immediately, I realize, wow, this is the restriction number one because it's the division to function. I don't care, the numerator is not important. You take the denominator, you enforce it, que no zero. It's a restriction. For me, it's a little bit confusing using that symbol. I feel more comfortable using that symbol. Equal. Because this is a quadratic equation. Exactly the same we are doing before, no? Now, well, this and this are completely complementary. So this is completely the opposite of this. So in this case, when you find the solution for the quadratic equation, this is the good guy. However, in the restriction is the bad guy. Okay, entonces let's solve this quadratic equation by factorization. I suppose que es easier. The combination is 3 and 1. Wow, 3 and 1. 3 and 1. X. 3 and 1, because 3 times 1 is 3, and somehow 3 minus 1 is 2, entonces negative and positive. Okay, entonces x minus 3 equals 0, then x equals 3. X plus 1 equals 0, x equals negative 1. Okay, entonces basically, in my mind, I suppose que 3 and negative 1 is a bad guy. So when I do in the all real number line, I suppose in my mind that this is x-axis. Okay, basically, we have inside here, this is 0. We have 1, 2, 3, 1, 2, 3, and 3 we have here, a whole in 3, because it's a restriction. So you plug in 3 here, 3 minus 3 is 0. 0 times something is 0, and division by 0 illegal. And negative 1 here, negative 1. So basically, we have 2 whole, and my domain is from negative infinity to negative 1, And between -1 and 3, I'm from 3 to positive infinity. That's how you write the final answer. Domain is then from -infinity, comma, -1, parenthesis, no bracket, of course, union, -1, comma 3, parenthesis, union, 3, comma infinity, because we have 1, 2, and 3 intervals. So our domain contains 3 intervals. Any question? Super easy or super complicated?
Can you do another example?
Of course, I have 1, 2, 3, 4, 5. Let me see, 5, 6, 7 example. Don't worry for example, miss. This is just the beginning. But it's clear or it's confusing? Clear or confusing? It's my concern. Clear. Lustig say clear, professor. Okay. Let's see another case. Number 2. Example 2 is similar. Similar, no. It's not similar. The name of the function is g. And this is a square root 3 minus 2x. Well, I remember 1, 2, 3 restriction. Restriction number 1 is P over Q, and Q not 0. Restriction number 2 is radical E non-negative, so positive 0. And restriction number 3 is P over radical E must be positive. You keep in mind this idea. In this case, matching perfectly, in my opinion, number 2, no? Because it's a radical. Then you take the expression inside without radical, the radical is gone, and you enforce it to be non-negative. And you solving this elementary inequality. Let's do it. Minus 2x greater than or equal, I move 3 to the other side, like a minus 3. Finally, divided by -2, because my goal is solve for x. Entonces x. Entonces, when you divide by negative number, this is classical in inequality solutions. When you divide by negative number or multiply by negative number, so when the multiplication or division involve negative number, you have to reverse it, the inequality sign. This is 3/2. Positive, no? Because negative divided by negative, positive, no? Okay, let me try to understand this. That the domain of this function is, okay, this is again my famous line. Okay, this is 0. Well, 3/2 is 1.5. Well, in decimal, no? In decimal, much better to see here. It's a 1, it's a 2, 1.5 here, 1.5, 3/2. Entonces less than or equal. Less than or equal means que es to the left, because it's less than, no? Less than. Incluye 3/2, of course, incluye 3/2 incluye. Entonces, the symbolic way to indicate this idea is using a square bracket. It's a square bracket because it's equal, guys. When it's not equal, it's parentheses. When it's a square bracket. So this is minus infinity. So the domain is then, the answer, final answer, is from -infinity, comma 3/2. 3/2 or 1.5, either way, using fraction or using this. Here, bracket. End of story. Any question? Was it easy or not? Good, very good. Andreina. Okay, let's go example 3. Remember, we have 7 examples. 7. No question. Example 3 now. This is important, guys. In the test, you can see at least 2 questions like that. The name of the function in number 3 is h of x is equal 4 divided by square root x minus 9. Entonces, immediately I remember this idea. I suppose this matching perfectly with the restriction tree, no? And the restriction tree is when the E is positive, who is E in our example, x minus 9. So x minus 9, clear answer. And you solve in this elementary kindergarten inequality, x greater than 9. Now, the crucial moment in which you write in interval notation. Interval notation. I recommend, strong recommend, do the graphic part. And this is not too important, but another more complicated example, you have several restrictions. Basically, you end in the problem in compound inequality. To say you need to solve the compound inequality. The last step of any compound inequality is graphic. Okay, don't worry. To say 0 here is 9. Suppose 1, 2, 3, 4, 5, 6, 7, 8, 9 is to the right because it's greater than. And to say domain is this part. Okay, and this is parenthesis because no include 9 because no equal sign. And it's logical because you blew in 9 here. 9 minus 9 is 0. Square root 0 is 0. 4 divided by 0 undefined. And another number less than 9. Suppose 8. 8 minus 9 negative 1. Square root negative 1 is I. It's imaginary. It's not real. That is the reason. So what is the final answer? The final answer is domain. Its column is 9, infinity. End the story. Okay, this is easy. Eh? Okay, I put it first the easy example. Now the complicated or weird, little bit weird. Suppose example 4. Guy, interrupt me if you don't understand something. Don't hesitate to ask me any question. Okay? We are the team and we working together to pass successfully this class. Okay? Okay, let's move on to number 4. Number 4, the function is p. The name of the function is p. Remember, the name of the function normally we express it using 1 letter, 2 letter, or 3 letter. No 4, no 5. Only 1, 2, or 3. And this is x over x squared plus 1. I suppose this belongs to the category p over q, and the domain is q not 0. Okay, this is the first category, remember, right? Because of the fraction, no square root. It's just a fraction. So you take the expression, the denominator gets x squared plus 1, and you enforce it to be not 0. Some student asked me, bro, professor, what is the participation of this? Nothing. The numerator have no participation in this problem. Another problem, yes. Now, I realize that we need to solve in this quadratic equation. When you solve in this quadratic equation, you see it now surprise. An interpretation of this surprise. You isolate the x squared because this is an easy quadratic equation that we can solve in using a square root method. And this is x, and this is, wow, it's plus or minus I. Imaginary. Imaginary. And imaginary is totally out the all real number. Okay, entonces la interpretation, sorry, being the professor was having connection issue. Okay, some students have connection issue. Okay, you get out and try again. Suppose that you cannot connect in one day. Remember, I posted this video on YouTube every day, or every day that we have class. Okay, don't worry, you try. Let me try to understand imaginary. So the restriction I found was imaginary. So what is the interpretation? The interpretation is the word that we are living is all real number. The restriction I found in this problem after setup, the restriction is imaginary. Therefore, in this word, que is all real number, maybe I suppose que es the Earth, the restriction live in Jupiter, in another planet, don't belong to the our world. Therefore, when you try to find something in algebra, que you suppose que exist, and the answer is imaginary or complex, it's because doesn't exist. So the interpretation of this is do not exist. Therefore, we have no restriction. We have no restriction in that function. Okay, professor. Entonces, what is the domain? What is the domain in this case? If we have no restriction. Remember the assumption. The supposition, the initial supposition is the domain you suppose que es always all real number. Boom, always. Aha! Lustig say all real number, professor. Okay, the supposition is all real number. Except restriction. Except restriction. Pero I discover que the restriction do not exist because they are imaginary or complex. Therefore, the domain is all real number. Nice. Any question? No? Super. No. Frank dice no. Okay, example 5. Example 5 is a little bit more complicated. Suppose f of x equal square root x plus 4 plus square root x minus 5. And the same question, no? Find the domain and express the domain in interval notation. Entonces I ask by myself, how many restrictions you have? How many restrictions we have? How many restrictions we have? How many restrictions we have? How many? No idea? Repetition again. 2 restrictions because we have 2 square root. Repetition again. We have restriction number 1, which is a fraction, and the divisor is not 0, illegal. Number 2, when you have a square root, an expression inside a square root non-negative, and restriction number 3, que es the combination 1 and 2, que es P over radical E, is E positive. Entonces, matching perfectly with the number 2 again. But in this case, we have 2 square root. Therefore, we have 2 restrictions. The first restriction is x plus 4 is greater than or equal to 0. Look here. The second restriction is x minus 5 is greater than or equal to 0. And you connecting both restrictions for and you form it in this moment compound inequality. Compound inequality. And what is the reason que es and not or? It's because you need to satisfy the first restriction and together mandatory the second. So this and this together is and. Or is not together. Or is this or this. So you satisfy at least one, it's okay. But no, because we have here undefined in this, yeah, screw up everything. Or undefined this, no, screw up everything. So you undefine both, worse. Okay, entonces, how you solve compound inequality? Easy. Exactly the same we are doing intermediate algebra. You solving one by one separately. Suppose this. X greater than or equal minus 4 in the story. And in that case, x greater than or equal 5. Positive 5, no? I move 5 to the right-hand side, positive. I move 4 to the right-hand side, negative, no? Okay, now when you solve them both, this is the most important moment in which you are doing the graph. The graph in this case is important when you have more than one restriction. Infinity, negative infinity. This is my line that represents all real numbers. However, I try to do the sketch for the restriction. This is 0 in the middle, 1, 2, 3, 4, and 5. 5 here. And this is greater than or equal 5. Greater than or equal 5 is from 5 to the right. Of course, bracket. Entonces, I want to do, no directly highlight this. No, 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 because I need to intersecting. Entonces, I propose you this technique. You are doing like that. No directly highlight this. No, 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 no. No, no, because this is not the final answer. Huh? Okay, this was this. Now, and the second is a -4, no? And -4 and -4 and -1, -2, -3, -4 is here, -4. Yes, from -4, including -4, of course, because it's equal. And again, it's to the right. In that direction, because it's greater than. Entonces, my goal is compute the AND connection. The AND connection between blue and green. What do you think? What is the common part in between the interval green and the interval blue? What is the common part in between the green interval and the blue interval? So, another easy word. What is the part that both interval share? Overload. Everything greater than 5. Super. Align reading. Everything. So, in other words, guys, let me use this color que is nice, rainbow color, is this part. Okay. Therefore, domain is bracket 5, comma, infinity. End story. Let me try to spend some second to understand the idea. Look. Okay, let me pick one arbitrary value here. Suppose 6. So you plug in 6 here. 6 minus 5, boy, positive. Nice. And 6 plus 4 is positive. No problem, no problem. However, so you pick one guy here, suppose 0, que es easy to understand, and you plug in 0 here. Let's see what happens. Bueno, 0 plus 4, 4, and square root 4 is 2, nice, no problem. This is a perfect define. But 0 minus 5 is -5, and square root -5 is imaginary. That is the reason that this 0 and this point is totally out of the domain, and our domain is only for 5 to infinity, include 5, because 5 is legal, because 5 plus 4 is 9, square root 9 is 3, and 5 here is 5 minus 5, 5 minus 5 is 0, and square root 0 is 0. Entonces, it's perfect legal, no illegal. Any question? Do you see the combination? Two radical, in this case, two radical combination. Question? No or yes? No. Okay, good.
So.
Go ahead. Go ahead. Question.
Yeah. So you guys have a 5. I mean.
Hey, feedback.
Echoing.
Feedback. Repeat your question, mister.
Okay. Is there feedback now?
Yeah, a little bit much better, but not totally
Okay.
clear. Okay. Try to speak clear and loudly.
All right, I will. So where'd you get the? So you took the 5 from both ends on f of x?
Yeah, I suppose. Look, what happened with the 5? What happened when the x is 5?
Because you have x minus 5, then you have 5 minus 5.
Minus 5. No, minus 5 is here. It's completely out of the domain.
Okay. Okay.
No. Our domain is the interval. This interval. Okay, I highlight here using rainbow color. Look.
Okay. Okay, I got it.
Okay, super. Let's move on to another interesting example and complicated example. Example 6. Look, g of x is the name of the function. It's square root 2x plus 1 divided by x minus 4. And the same question, determine the domain and express the answer in interval notation. I asked myself, how many restrictions you can see? How many restrictions you can see? Restriction number 1, restriction number 2, restriction number 3, fraction, denominator no zero, radical, expression inside the radical non-negative, and P over E is expression inside positive. What is the restriction que matching? With this example, 1, align say 1, and 2 no, align.
And 4.
Okay, this problem I can see using my eyes. Okay, we have fraction, division, something. Therefore, the condition 1 match 1 and 2, 1 and 2, 1 and 2, because it's division, something divided by something. And also I can see in the top part 1 square root. So basically, when you set out the restriction for this specific function, you combine the restriction 1 and the restriction 2. Okay. But let's do it in either order because it doesn't matter. So the first restriction is the denominator no zero. No zero. Illegal. And remember, always is and. The expression inside the radical non-negative. This is the restriction. End the story. The rest is solving this compound inequality, and do the graph. Any questions so far? It's clear or confusing? Okay. So this is X no 4. That means, clear. Yancy Maria. That means no X no 4. Let me try. Is boy. This is my line. Or real number. Arrow. I don't lie. Okay, let me try to do my best. I have a rule, but the rule is complicated. Which much better. Infinity positive, infinity negative. If you want to put a sign, plus, si you omit the plus, default you suppose que es positive. It's a 0. 1, 2, 3, 4. And 4, we have a hole. This is a hole. And the hole, you indicate like that. Boom. Now let's solve that part. That part is easy. It's 2x plus 1. Plus 1, no. 2x greater than or equal negative 1. Okay. 2x greater than or equal negative 1 divided by 2. And when you divide by positive, the inequality sign stays the same. Negative 1/2. Negative 1/2, I suppose this is negative 1. And negative 1/2, I suppose here. Negative 1/2. So this is greater than is in opposite direction, no? To the right direction, sorry. Including negative 1/2, and now is something like that. Bracket here, continue here, but unfortunately in 4 we have stop because in 4 we have a hole, and we continue here. Okay, ready. I understand very well. The graph is fantastic. And at least for me, I don't know. Domain is bracket negative 1/2, comma 4, parenthesis, union, 4, comma infinity. End the story. This is my domain. Super. Super or duper. Okay, you consider it enough, or we continue doing one more? I have to one more, no, one more. Enough, right? Do you understand very well, no? Do you understand? So you are familiar with the restrictions, the 3 classical restrictions, and how we combine this restriction in one specific problem. I suppose in the test, I don't put very complicated. No, you understand very well. So in the test, I promise, I don't want to put very complicated function, no? Maybe you have 1 or 2 restrictions, no more. Okay. Yesterday, I sent to you one document que is called library of the function. Library of the function. Everyone received this or no? Okay. What is that? What is that? This is the typical function that you need to memorize in color algebra, in any advanced algebra, because we are working with this kind of function. Okay, let me try to summarize very quickly the idea for the library of the function. This is a common function because this is like a basis function, and next class, next week, we are doing transformation of this. Okay, the first function is number 1. I want to summarize quickly. I suppose you have the document, and the document explain in detail everything. The first is a constant function. Constant. Constant is f of x equal a number. Arbitrary number, 20, 21, 25, 2, -2. One number. It's a constant. And the graph is a constant. It's horizontal line, like that. Okay? Number 2 is identity. Identity function is a line. F of x equal x. Remember, f of x is equivalent to y. So you can use in both f of x or y. It doesn't matter. Guy, I don't want noise. Who make a noise?
Oh, it's me. Sorry.
No, it's okay. It's okay. Putting off the microphone, and that's it. End the story. This is the graph of this. Is a line passing through the origin, 0,0, and slow one, and the y and z is 0,0. This is the identity. We're using identity, guy, in one moment, no? Number 3 is a square or quadratic function. Quadratic function is f of x equal x squared. This is a classical parabola. Parabola is interesting because the parabola is symmetric with respect to the y-axis. Do you see? Symmetric. When you flip it up, stay the same. Symmetric. In next class, we study in detail symmetry of the function. Number 4 is a cubic function. Cubic function is x to the cubic power, no? And this is completely different. It's something like that, the graph. It's one special symmetric, but no with respect to the y-axis. It's another symmetric I want to study next week. But it's important that you, for example, the family of the power function, que the exponent is even, look like that. This is quadratic, x squared. This is, for example, x to the 4th power is similar, very similar. Very similar, open in this direction. So the end behavior is similar. But of course, x to the 4th power increasing faster than x to the 2nd power, no? But in between -1 and 1 is a little bit flat, like that. Suppose to the 6th power, increasing faster, and this look like a square here. But no, actually it's not a square. Same idea happened when the exponent is odd number. This is even. Power function even. Power function odd. So cubic is something like that. A little bit smooth. Cubic. Now to the 5th power is something like that. And to the 7th power, something like that. Okay. The most important is the shape, the symmetry, and have approximately what does it look like, that function. Okay, what is the number 5? Well, number 5 is a square root function. Very important. The square root. Square, sorry. The square root. Square root. The function is square root. And the graph, unbelievable, is only like that. We have no graph in the negative part. What is the reason, professor, that we have no graph in the negative part? Because the domain of this is x greater than or equal to 0. You take the expression E inside, you enforce it to be non-negative, and we have no graphic in the negative part. No, because it's totally out of the domain. Only the domain is positive number 1, 2, 3, 4, and of course the decimal, the fraction number in between. Okay, number 6 is cubic root. Cubic root is more interesting. Cubic root have domain is in both directions. Because, let me try to explain. I know que it's totally illegal. Square root negative 25, negative number, it's imaginary. But it's perfect legal. Square root negative 27. So it's a negative number. Okay, this is no real solution, You know perfectly. But this is real solution, is negative 3. Because according to the definition, cubic. I forgot the 3 here. Because negative 3 times negative 3 times negative 3, negative 3 times negative 3 is positive 9, and positive 9 times negative 3 is negative 27. It's exactly the number that we need inside the rad. Okay? Therefore, the domain, the restriction that you apply is only when the square root or when the index of the root is even, like a 4, like a 6. But when it's odd, like a 3, like a 5, like a 7, it's all real number. Domain is all real number. Okay? Well, number 7 is a reciprocal. Reciprocal is flip over, no? 1 over x. And reciprocal, the graph look like that. Because the only restriction that we have is not 0. The denominator not 0. So in other words, the domain for the reciprocal function is all real number except 0. 0 is the only bad guy that we have here. So basically, see, I try to do the domain. Domain is something like that. We have a hole here. And continue. Okay, reciprocal. And finally, number, we have one more, but no, it's not important. Number 8 is absolute value. Absolute value f of x equal absolute value x. The graph of the absolute value look like similar to the B, like that. Look, xy, like that. Because regardless if the number is positive or negative, the absolute value is the same. And it's obvious that the domain is all real number. Domain is obvious, it's all real number. We have no restriction in the domain because this continues forever in both directions, similar to the parabola, no? Okay, like that. But the range, no. The range is the value you expect of the y value is only positive. Okay, it's bracket 0, infinity. Because remember the range is the projection in the y-axis. And the projection in the y-axis is only positive. We have no value in the negative part. However, the domain, no. Domain is in both directions. Super? Do you understand or no? More clear, you can see in the document I sent to you, and you using every day for the okay. Well, okay. Let me try now to explain another topic. See, you have no question about the function. I have also the Desmos to illustrate this, but it's okay. Well, I try to show you. Let me show you. Let me spend the time with this. Okay. Let me share screen. Look. Wow, Desmos. Okay. Do you see Desmos? Do you see? Oh no. Yes. Okay, look, constant. This is a graph, horizontal line. Identity, linear. Especially linear, ¿no? Que es lowest one and passing through the 0,0. Quadratic, parabola. Every student que take college algebra need to somehow memorize this function. Cubic, like that. Square root, only positive part, no negative. Cubic root, positive and negative. Reciprocal, something like that. Remember, domain is all real number except 0. Absolute value, boom, look like a B. And the last one, is very, very confusing. See one I explained, but no important. It's graded integer function, que look like stairs, like that. And maybe see you have time because we need to cover one complicated part now. I can explain this, but no, it's not important. Okay. We come back to the whiteboard. Should we switch to whiteboard? Okay, do you see whiteboard? Okay, I want to erase everything. Okay, let's go now to the piecewise function. Okay, piecewise function. Okay, piecewise function. Okay, piecewise function is a function that you cannot define using only one piece. You know, you define using multiple pieces. And the real life is so built que in the complicated problem, you cannot model the problem mathematically using only one expression, no? Using several. Okay, one elementary example to understand this is the formula, for example, the formula to compute the price of the ticket violation in the school, speeding school in traffic. So you speeding in the school zone, and you know very well this, the ticket is too expensive, it's $300. It's stupid. Entonces there are a formula que si you travel 10 miles per hour, no ticket. But si you travel 15, and between 10 and 15, it's $200. I don't remember very well, but this is the idea. And between 15 and 20 to 50. And after the 20 miles per hour, it's $300. Wow. So this is a typical example in the real life elementary in which when you define the function, can model somehow the real life situation, is no possible doing in only one function, no? Cubic function, square root function, reciprocal, no. Sino it's a combination, several functions together. So what is the idea? Let's see example one to understand piecewise function. And what is the idea behind piecewise function? Suppose the symbolic way to represent the piecewise function is something like that. You open a big curly bracket and you listing here the different formulas. Suppose the first formula is minus 3x plus 2. And this is valid if you put a condition, x is less than negative 2. Okay. The second is x squared plus 1 if x is in between -2, and +3. Okay. And the last one is 4, que is a constant function, just constant, if x is greater than or equal to. Okay, this is a given. You don't need to do anything now. You need to understand. That what is the idea? Let me try to illustrate graphically, que in my opinion is clear. Suppose again, our famous Orion number line. Positive infinity, negative infinity. And the transition, this is 0 in the middle. Transition point is -2. Look, -2 participate in the game. And +3 again participate in the game. 1, 2, and 3. Entonces, in the interval, I want to put in different color. Blue is this. No included -2. So the symbolic way to indicate this idea is parentheses, no bracket. The formula is this. The formula que es value is this. -3x + 2. See, our value of the domain belong to this interval, blue, you using that formula, blue. Now, here, see, our value in the domain belong to this interval, que es bracket, and 3 parentheses, we using this formula. And finally, see, our interval belong to this, to value belong to this interval, okay, this is a bracket here, we need to using that formula, que actually is no formula, it's just 4, it's a constant function. Entonces, okay, let me try to solve some problem. What is the idea? The idea is, this is given, this is the interpretation of this. This is graphic interpretation of this. But in the question, in the test, I don't give the interpretation. You need to understand by yourself, and I need que you evaluate the function in -2. Sorry, in different point. -2, carajo. -2. Suppose que yo evalúe en -3. Suppose que yo evalúe en 0. And suppose que yo evalúe en 5. Let's do in this 4. After each one, let's do it more. Okay, entonces, the process is clear. The process is, you recognize -2. Well, -2 is here. Pero actually, -2 belong to this interval, not this interval. Because I don't see equal sign, I see equal sign here. Therefore, the selection of the expression is this, the second one. And you plug it in using this convenient notation such that x equals -2. And -2 you plug it in here. And the answer is -2 squared. Be careful with the parentheses. And -2 squared is 4 plus 1 is 5. And the answer is 5. Do you understand or is confusing? So, step number 1, recognize in what interval lie the given point. In this case was -2. Secondly, selection the expression que corresponde with this interval. And finally, evaluate into this. -3. -3 is here. Look, -3. And -3 lie absolutely inside the blue interval is this. Not this. Entonces, the selection is, you take the expression that -3 plus 2, evaluate at x equals -3. -3. And plug it in. Be careful with the sign. It's -3. Multiplication -3 plus 1, plus 2, sorry. Plus 2, no? Plus 2. Dice 9, positive 9, plus 2, 11. Let's see. Final answer, 11. So f en -3 is 11. And 0, 0 is here. And 0 below corresponding with the blue, with the green, sorry. And green is the expression x squared plus 1. Evaluate at 0. 0 squared plus 1 is 1. And 5 is here. This is 4, this is 5. And 5 lie in the rainbow color. And rainbow color is this. And the answer is 4. And this is not depending of x. This is totally independent of x because it's a constant function and the answer is 4. End the story. For example, help me. Suppose I need to evaluate in positive 3. Evaluate in positive 1. Evaluate in negative 1. Evaluate in negative 4. Okay. And positive 3. Let's focus on positive 3. Positive 3 is confusing because positive 3 is the transition between the green interval and rainbow color. Pero I know que belong to the rainbow color because it's bracket. You select the bracket part. Entonces 4 belong to the rainbow color. Entonces the answer is just 4. Guys, do you follow me or no? Eso, bueno. Yes, good. Negative 1. Well, negative 1 is here. Negative 1 is here. And negative 1, I select this expression, que es x squared plus 1. And you plug in x equal minus 1. Grande. Okay, entonces negative 1 square plus 1. Negative 1 square is 1 positive, no? Plus 1 is 2. 2 and 4. Positive 1, similar. Here. 1 square plus 1. It's 2 again. And negative 4 is here. Negative 4 is here. Therefore, you select the expression negative 3x plus 2 evaluate at negative 4. Entonces, substitution is negative 3 times negative 4 plus 2. And negative 3 and negative 4, multiplication is 12 plus 2, 14. End the story. Any question? Okay, this is my first kind of question about the piecewise function, no? The piecewise function. I have another, and you let me know to understand this. We have two different problems about concerning about piecewise function, no? This is the first one, que es evaluate, understand the symbolic way, but the second is do the graph. Pero, okay, let's do one more example of the evaluate, que is, in my opinion, the easy part. Okay. Pero now you help me. Suppose the function, okay, the name of the function is g. Entonces, this is given. And that way, look at that. Es 1. The expression if x is less than negative 1. When it's 1 is a constant. This is x minus 1 squared. This belongs to the parabola, no? To transformation. If x is in between negative 1 and 2. And the last expression is 1/2 x minus 2. If x is greater than 2. Okay, this is given. Because I want to evaluate g and negative 5. G and 0. And g and 2. Negative 5. Negative 5 belong to the first, to the second, or to the third piece. What do you think? Negative 5 to the first is obvious, and in the first, the expression is just 1, not depending on x, and the answer is 1. Done. Andreina, done. 0. 0 belong to the first, to the second, or to the third? To the second, very well. To the second, well, immediately you recognize que to the second, you copy the selecting expression and you evaluate at 0. Be careful with the sign, be careful with the parentheses. Entonces 0 minus 1 squared. 0 minus 1 is negative 1 and negative 1 squared is positive 1. Oh, it's a coincidence. And Jan2 belong to the first, to the second, or to the third? Be careful. To the second, very well. To the second, Frank, because it's equal here. Okay, 2 is the transition point, so you need to be careful with the transition point because you need to know, you need to understand belong to the second or to belong to the third. 2 is the transition in which change the second piece to the third piece. But 2 belong to the second piece. So you copy again the same expression, x minus 1 squared, but you evaluate now 2, such that x equal to 2. So plug it into here, 2 minus 1 squared, 2 minus 1 is 1, 1 squared is 1, the answer is 1. Wow, entonces everything is 1. Yes, in this problem, the solution is 1, 1, 1. Do you understand very well piecewise function? At least that part. At least that part. At least that part. Okay, that part is just evaluate, is you recognize in what interval lie, and you selection the properly expression, and you plug it inside this. Okay, this is my first problem. My second problem is a little bit more complicated, but I want to explain using by hand first and using decimals secondly. Is how you are doing the graph of the piecewise function. How we are doing the graph of the piecewise function. Let me start for an elementary example. Elementary example first. Okay, suppose this piecewise function is given. Minus 3 plus x if x is less than 1. And 4 if x is greater than or equal to 1. Okay, in this case, this piecewise function contains 2 pieces. Maybe 2, maybe 3, maybe 20 pieces. But in this case, in the test, no, 3 and 2. Okay? But what's the question now? Do the graph. Do the graph. Do the graph of this piecewise. I want to explain it by hand, and after I want to explain in decimal. Okay, fantastic. Let me try to bring the rectangular coordinate system. I have here one image. Okay, let me enlarge a little bit. Okay. I suppose it's good. Okay. Okay, entonces I have no idea, I'm totally lost. However, I know that my function contains 2 pieces. This is my first one. Entonces I recognize, I copy here in one corner, que y is equal to minus 3 plus x. Ooh, it's a line. This is the equation of the line. Remember the equation of the line in general is mx plus b, no? See, I organize this to understand much better. This is x minus 3. It's the same, no? So this is a line que the y instead get b is negative 3. I plot that. And the slope is 1. Because m slope is 1 in our specific. Slope 1 is 1, row and rise here, another point. And we connect this point. And this is the graph que represent the first piece. Let me put a label to identification. This is first piece, que es -3 plus x. The label is important because we have several pieces. Entonces hay confusing. Oh, using different colors, no? Right. Okay. The second piece is easy, it's 4. And 4 is y equal 4. And y equal 4 is horizontal line. Passing through 4. No slope. Oh, no slope, no, slope 0. Okay, if you want, you put the arrow here. And you put the arrow here. Okay, so the thing we are doing so far is, this is 4. Do the graph of each piece separately. Okay, that's it. No, this is just the beginning. Now I recognize transition point. Transition point is in 1. So in 1 is a point in the domain que change, switching the graph. 1 here. Therefore, I do a dotted line like that. Dotted vertical line. And this dotted vertical line split the plane in 2 semiplane. 2 semiplane. Before 1 happened one situation, and after 1 happened another situation. Before 1 is this. It's obvious, right? Before. So we travel before, let me use in rainbow color for the final answer. We travel on the line here because this is the equation for the line. And after 1, we travel for the 4, que is the horizontal line, like that. Okay. We almost finished. One last detail. Okay, if you want, you can erase everything except the rainbow color. This is history, and this is history. Okay, and rainbow color was this line until 1 touch 1 here, pan, and here. Okay. What is the last detail? The last detail is in the transition point. We have here 2 que I don't know si es whole o es, o sea, si es open o es closed. Es obvio que here is open because no equal. That's the reason que this is open. And this is closed because it's equal. Okay, and this is our famous graph. Question. Complicated or easy? Complicated or easy? Very, very complicated or easy? Easy, he says easy. Entonces too many details. Remember, it's important, at least for me, it's super important. When in the transition point, si it's open, si it's closed, you know, it's very, very important for me. Okay. Let's do exactly the same example now. The same example, guys, the same, but using Desmos. I want to open one section of Desmos. I want to do exactly the same. So take a picture of this because I want to do exactly the same, not by hand, using Desmos. In the test, I highly recommend you using Desmos. Okay? When you finish, you print out the answer. Okay, let me go back to Desmos. But let me open one new section of Desmos. New and blank. Okay, let me share the new screen here. Switching Desmos. Do you see Desmos? You see? Good. Okay, let's try to do the same problem using Desmos. Let me change a little bit the proyecto mode to see much better. Entonces I copy my first piece of the piecewise function that was, remember, -3 plus x. -3 plus x. Okay, I like so much open the keyboard for Desmos cases. Plus x. Bang! I can see now the line. Do you see? The same line. But this piece is valid for the condition. Entonces, in Desmos, how you typing condition? No if. No. This is a specific language of the Desmos. You open this curly bracket and your specification inside. The condition gets x less than 1. Boom. Boom. Bada boom. Look at that. Okay? Immediately remove that part. This is the piece we need. Okay, I press enter and I copy the second part. The second part is easy, it's just 4. If you want, guy, you put y equal 4, doesn't matter. So you omit the y, Desmos understand very well it's y. Like here, it's y. This is y, no? Okay, let me see, y equal, doesn't change. And the condition is curly bracket, curly. Entonces x greater than or equal, I like that, this keyboard, greater than or equal 1. Boom. And this is the graph of this. Okay, but the important part, professor, what is the important part? The important part is the transition point. See, it's open or it's closed. So we have here one point, okay, by the way, is 1, -2, and so here, 1, -2. Boom. Okay, no, I don't like the green color. I change to red color, no? Red color. Wait. You click, hold the mouse. Up with my mouse. Hold the mouse. Wait. Hold the mouse and you change the color. And you change the style because this is open. Okay? If you want, you put a label. No, this is totally optional. No, it's okay. Now, in other line, because of different color and different style, you put the other point, okay, 1,4. 1,4. 1,4 is blue. And this is completely closed. Entonces, the point is a full circle. And this is my final answer. Now in the test, you click here, share a graph. You select maybe export image. And that's it. And you download and send me back. Attach with the email. Any question? Any question? Are you tired? No? Okay. Let's do it one more. Let's do it. Okay, listen to me. Now, let me call this example 1. So I click here, select folder, add in one folder, I assign any title, maybe example 1. I put here, click and drag. Let me see, drag to connect it with the folder. And you click here, done. Now let's do example 2. Another folder, example 2. for the test, he want to send the, yeah, of course, yes. See, the question say, do the graph of the piecewise function immediately. So any graph I ask you in the test, you open Desmos. No necessary graphic paper, no pen, and you take a picture. No. You create Desmos. Desmos is our fantastic graphic calculator. When in the test, in the syllable, you can see February 2nd, I suppose. Syllable. February 2nd. Do you have the syllable or no? Do you have? Oh, okay. Take a look. Let me go back again to the whiteboard. Do you see whiteboard? Do you see or no? Good. Okay, let's do it one. I promise it's the last one, guys. And we take a break. Too much. Suppose this. Let me try to find one easy. See, this is good. This is good. I like this. F of x equal x squared if x is in between -2 and 2. And 2x minus 1 if x is greater than 2. Suppose this. And then we are doing exactly the same. Do the graph. Okay? It's the question. But no. We are doing no by hand now. We are doing using decimals. Okay? In the real life, we are using decimals. Any graph, piecewise function or no. Decimals help you to understand the problem. So I switch into decimals. Now. This is example 2. Okay? Okay, switching to decimals. We are in decimal or no? No? Yes or no? Yes, okay. Okay. Entonces, the function is, the first piece is y equal x squared. Parábola, you see? Parábola. Pero this parábola is valid. The curly bracket. The curly bracket, I in this moment, I press it directly in my keyboard of the laptop computer. However, we have here in ABC, curly bracket. Look at that. I don't know why I prefer directly in my keyboard. And you put a condition. The condition is -2. Less than or equal x. Wow, do you see one piece of the parabola, no? And less than again, +2. Boom. And this is my parabola. Okay, super. What is my second piece? Well, my second piece is y equal what? Y equal 2x minus 1. ¿Qué es el line? 2x minus 1. Oof, it's a line. But this line is valid only the condition is X greater than 2. X greater than 2. Boom. And this is my piecewise function. Okay. Entonces, -2, the transition point, -2, +2, here is equal. Entonces, equal say que es, the circle is closed. Entonces, es 2 point, que es -2,4. -2,4. Do you see que the y value is 4, no? Boom. And also, +2, comma, separated by comma. We can put, when the point have the same characteristic, the same features, you can put together each one, no? 2,4. Pongo. And this is maybe black color. Black color. And this is solid, of course. Okay, super. But we have another point. But it's not the same category because it's red color and open, no? Que es at the point 2,3. 2,3, ahí que so. Let me say, si I make a mistake or no, guys. 3. Chung. And this is red color. The same color. Off. Red, but this is open. Here you go. This is my graph. End the story. I finish. Wow. Guys, enough for today. Take a break, you deserve. Next week, we start the complicated part graphically. So I would like you practice a little bit Desmos, no? Remember, this is the beauty of Desmos. You put it here. You put the name of the folder. This is Piecewise. Function. And you save. And your account. Maybe you put in blank everything. And you want to see example 1, example 1. You want to see example 2, example 2. It's fantastic. Okay. Guys, we finish. I love you so much. I appreciate it. I enjoy teaching you. Enjoy. You are the best. Okay? And don't hesitate to have any question. Remember, start as soon as possible. This weekend, I want to see that you are working in the homework. I understand very well that you don't know something and ask me, to me or to Cesar. Cesar is waiting. Cesar want to work, and I want to work also. Okay? Bye. I will post this video on YouTube today. I have another class now.